So nuclear force, proton and the neutrons are inside the nucleus. We know that same charges are repel each other. Then proton and protons are inside the nucleus. So two protons have the same charge, that is positive charge. So definitely they will repel each other. But inside the nucleus it is a stable because very strong nuclear force acting between the two protons. That force F is equal to K into Q square by R square. Substituting that you will get the value of 230 Newton force is acting between the two protons. So by using the acceleration A is equal to F by M or F equal to ma from the formula we derived A equal to F by M. Substitute that value you will get 1.4 10 to the power of 29. This value is nearly 10 to the power of 28 times greater than the acceleration due to gravity. So it is very stronger compared to the gravitational force. So very strong attractive forces acting inside the nucleus. So the Coulomb's electrostatic force overcome by the strong nuclear forces acting inside the nucleus. So 1913 and 1950, the experiment was carried out. From that, they have concluded that so strong nuclear forces acting between the two protons and the neutrons, then proton and neutron. So here, the distance between the two proton and neutron and proton is very small, 10 to the power of minus 15 meter. The nuclear force is a very strongest force. It's acting between only the 10 to the power of minus 15 meter. So this force is an attractive force acting between the proton, proton, neutron. Then the strong nuclear force does not act with the electron because the range is very small, so it does not affect the electron. So there is no change in the chemical energy. Next thing is radioactive. Radioactivity, we know that the heavier element, that is mass number is greater than 82, it is not a stable element. So it will disintegrate and radiate the energy. So spontaneous emission of highly penetrating radiations of alpha, beta, gamma rays are called the radioactivity. And the substance which emits the radiation is called radioactive element. So here the radium is example for radioactive element, and the smaller element carbon 14. Carbon 14 is also a radioactive element. And here that spontaneous emission, that for an example, you can take the uranium. Uranium is radiated the energy and it gives the two new element, barium and krypton. Here, the two particles are moving the kinetic energy. The kinetic energy is given or it is get from the parent element or the uranium element. So uranium element, small amount of process converted into energy. That energy is used by the that other particles or the radiation emitted from the particle. So this was that radioactivity was discovered by Henry Becquerel in the year of 1896, and Marie Curie and Marie Curie was made like the continuous experiment, and he demonstrated the so many things. And in India, Saga Institute of Nuclear Physics, and Kolkata it has another one is Institute of Pursuing Active Research in Nuclear Physics. Other two institutions with working in the India. Next thing is alpha decay. Alpha decay, the diamond emitting the alpha particle and produces the new element. So the mass number decreases by 4, the atomic number decreases by 2. So for example, uranium, this emits the alpha particle, this is the thorium, 234, 90, at 4 and 2, that the alpha particle is emitted from the uranium. The total mass of the thorium and the alpha particle is not equal to the uranium. Because small amount of mass is converted into energy, that is called the decay. That is NX minus 1, other gamma and alpha are the mass is converted into energy. So it is radiated the form of energy. So Q equal to, that is energy equal to M C square. So M is C square. So multiply the amount of energy radiated by the atom in the alpha decay. Next thing is beta decay. Beta decay is the electron is emitted in the electron and the positons are emitted in the beta decay. The electron and positons are the same nature. So all the parameters are equal except the charge. Electron and the positons are similar. They have same mass and everything is same except the charge. Electron has the negative charge and positon has the positive charge. In beta minus decay, the electron is emitted and the antineutrino is emitted. There is no change in the mass number, but atomic number is increased by 1. So how that atomic number is increased by 1? By neutron is gives the one proton, electron minus and antineutrino. So that proton is added to the Z plus 1. That's why that Z plus 1 is here. The proton is added to the new element. That carbon 14 is example for that. Carbon 14 gives the nitrogen 14. Here 6 equals 7. So electron plus continue. But in a beta positive decay, the new element emits element X is emitting the new element Y. That mass number, there is no change in the mass number, but atomic number is released into Y 1, and it gives the positron plus neutron. Here the proton emits the neutron plus positron plus neutron. So, for example, for that sodium 22 11, it gives the neon 22 and 10 plus positron plus neutron. So, all the words are that here the word neutrino. So, neutrino initially, when the before discovering that neutrino, the total mass of that parent element or the element which is giving the given out the new element and the other particles, that law of conservation of energy is not satisfied because some small amount of energy is missing. Then the scientists are conduct the many experiments. Then finally, in 1931, W. Pauli proposed that the third particle is must be present in beta decay to carry out using the small amount of energy and amount of. So later, Fermi named that particle as a neutrino. It is a little one. It has no charge, very little mass. So it is not interacting with any particle because there is no charge. So many years neutrino symbol is writing it with mu. Okay. So experimentally, finally, neutrino was detected by 1956 by Frederick Rains and Friedrich found. So he got the Nobel Prize in the year of 1995. The nature of the neutrino is it has zero charge. It has an antiparticle called antineutrino. The recent experiment shows that the neutrino has every tiny mass and it is not interacted with the any particle. So the sun is emitting the trillions of neutrinos. So large amount of neutrinos are passing through the human body or other things without affecting because it is not interacting with any other particle. Then finally, gamma ray. So gamma ray is nothing but that radiation. Already we know that gamma ray is an electromagnetic radiation. So that element which is in the excited state, it's emitting the new element plus that energy. That energy is radiated in the form of gamma rays. So beryllium 12, it is in the excited state. It gives the carbon 12 as electron, and no, it is not a carbon 12. So beta decay electron minus and antineutron. So now the carbon 12 is in the excited state. It gives the carbon 12. It's a ground state and gamma. So this will explain the diagram. See that. So initially ground state, the electron is in the ground state. Then it is excited, absorbing the energy and excited into the excited state. Directly it comes to the ground state means it emits the energy of 13.4 mega electron volt. Or the electron emits the energy of 9 mega electron volt and it comes to the metastable state. That is excited state. Then it releases the energy of 4.4 mega electron volt. The 4.4 mega electron volt is the gamma ray. Then law of radioactivity. Radioactivity decay. So all the atom radioactive elements are decaying because it's emitting the particle continuously. It will get decay. So bulk material or the sample material, whatever it is, contained amount is for some days it will decay and definitely it will decrease. So to calculate that, we are not able to calculate at each and every atom. So we are roughly calculating that probability. What is the sample of the amount of sample is decayed in the period of time t. So here we are going to take that any stop time t, the decays in the unit time is called rate of decay. That is dn, change in number of atoms divided by the time period dt. So dn by dt. That is directly proportional to the n, where n is the total number of atoms present at any instant of time in the decay. Okay, so dn by dt is directly proportional to n. So directly proportional to n. Here, proportional is there. To convert that equal to mark is here. So you have to put negative sign. So negative sign indicates that when time increases, number of atoms decreases. Where lambda is called decay constant. Right? So here the dt is brought it to other side. So this is written like this. And n is moved to opposite side. So dn by n. This is for only the small amount of element. We need the total sample decay value. So you have to integrate that value. So integrated means you have to integrate the family, integrated the value from n0 to n, where n0 is the initial number of atoms, n is the number of atoms at present in the equation, at present in the decay. And time period starts from 0 to t. The dn by n is write that ln n by n0 is a formula, and minus lambda is here. Integral of dt will get t. Then ln, substituting the value of upper limit minus lower limit, we can write like this: n by n0 equal to minus lambda t. Or taking exponents on both sides, you will get n. The ln cancel this side. You will get e power minus lambda t. So n is goes that side, you will get n equal to n0 e power minus lambda t. So e power ln x equal to e power x. See, initial amount, total amount of number of atoms is n0. That is 100. Suppose you can take that rate 100. This is the time period in x-axis. When time increases, the number of atoms starts to decrease. Initial atom is 100. After that, it will decrease n0 by 2, that is 50% for the time period of half-life period of t half. Another half-life period is 2t half. It will reduce to n0 by 4. That means 100%, 50%, 25%, 12.5%, 6.25%. So continuously it will decreases, and it takes time to completely disintegrate. It takes time to infinity. See the graph here. It does not touch the x-axis. It will not touch because this decay constant, it goes up to infinity. So every atom takes time to completely disintegrate. So it takes time for up to infinity. See that where R is the radioactive, or the rate of disintegration. Okay, rate of disintegration is the radioactive, or R. R equal to dn by dt, that is equal to lambda into n0 e power lambda. Or you can write R equal to R0 e power minus lambda. So you will get the same value from this equation. So R0 equal to what? Lambda into n0. So instead of lambda into n0, you can write R0. Then R equal to lambda n. So you are writing like that, you will get R equal to lambda into n. N equal to n0 e power minus lambda t. Or R equal to R0 e power minus lambda t. So this is called radioactive law of disintegration. This is called radioactivity. And the number of atoms disintegration per second. Here 1 curie is equal to 3.7 into the power of 10 decays or disintegration per second. So this is called 1 curie. Or 1 curie equal to 3.7 into the power of 10 becquerel. Becquerel is also disintegration per second.